Today, we are diving into one of the most ambitious projects in science, really, the quest to map the human mind. And we're not talking about using words or philosophies, but with the most precise language we've ever come up with, mathematics. Okay, let's get into it.
It sounds like something straight out of science fiction, doesn't it? I mean, can you actually write an equation for a decision, or a memory, or even a feeling? Well, there's this fascinating and, pretty complex field called mathematical psychology that's trying to do exactly that.
And believe me, when I say complex, I really mean it. You have researchers building models that look like this.
And like this one, which is trying to figure out how the brain processes information over time.
And even this, a model for something we've all felt, that trade-off between going fast and being accurate on a test. Now, I know it all looks intimidating, but the goal behind all this complexity, it's actually really simple, to create a blueprint of how we think.
So, to make sense of all this, here's our game plan for today. We're going to start with the basic puzzle, then we'll explore how we model choices, how we learn, how we perceive the world around us, and finally, why any of this stuff actually matters for the future.
First things first, let's just lock in the foundational idea here. We're talking about thinking of the mind as a system that can be described, that can be modeled, and ultimately understood using mathematics.
Now, what's really important to get is that mathematical psychology isn't trying to reduce our amazing human experience to just a bunch of cold numbers. No way. It's about using the power of these models to create hypotheses we can actually test, hypotheses about the hidden machinery inside our own minds. It's kind of like being an architect for how we think.
Okay, so let's move into the first major territory on our map of the mind, the world of choice and risk. Every single day, we make thousands of decisions, right? From what to eat for breakfast to huge, life-altering stuff. So how on earth can math even begin to model that?
Well, the answer is you start by breaking it down. You just begin with one simple choice and try to figure out all the variables that are at play.
What's so cool about this is how it shows this isn't just a job for psychologists. You've got concepts from economics, things like strategic pricing and risk, that overlap almost perfectly with psychological ideas like decision theory and judgment. Both fields are really trying to solve the exact same puzzle. What makes a person choose A instead of B?
And this is a perfect example. The work by Tversky and Kahneman, which is absolutely fundamental to behavioral economics, uses mathematical models to show that our choices, well, they aren't always rational. We don't weigh objective odds. We weigh our feelings about those odds, you know? That 1% chance of losing something feels way scarier than a 99% chance of winning feels good. And these models, they help explain exactly why that is.
All right, next up, let's explore the dynamic architecture of the mind, how it literally rewires itself when we learn, and how it stores all that information in memory. This is where things start to get really intricate.
I mean, this is one of the biggest questions in all of neuroscience, right? And to even start to answer it, researchers need a whole toolkit of different mathematical ideas.
And what a toolkit it is. You've got models like neural networks, which try to mimic the brain's actual physical structure of all those interconnected neurons. Then you have things like Bayesian models, which treat the brain like a prediction machine that's constantly updating what it believes based on new evidence. There are even models that focus on reinforcement learning, which mathematically describe how we learn from rewards and punishments, basically modeling the carrot and stick approach our brain uses to figure out what works. It's really a multi-pronged attack on this problem of how experience turns into knowledge. So our brain makes choices and it learns, but how does it even know what's going on in the world outside? This next part is all about that little magic trick, turning raw, messy, sensory data into a coherent, meaningful experience.
Just think about it this way. Sensation, that's just photons hitting your retina, or sound waves hitting your eardrum. It's noisy, it's incomplete data. Perception, on the other hand, is the rich, stable 3D world you actually experience. It's the story your brain tells itself about what all that messy data most likely means. The mathematical challenge here is to model how the brain writes that story.
And here is a fantastic example from a model of 3D vision, or stereopsis. See, each of your eyes gets a slightly different image of the world. So how does the brain know which point in the left eye's image matches up with which point in the right? Well, this model suggests it uses a Bayesian approach. It makes a best guess based on a built-in assumption, a prior, that smaller differences are just more likely. It's a mathematical description of the brain taking a kind of statistical shortcut to build a 3D world for you to see. Pretty wild.
So, we've seen models of choice, of learning, of perception. In this final section, let's zoom out and ask the really big question. What's the point of all this? Why are we trying to create this mathematical blueprint of the mind? Well, the impact is enormous. Seriously. These models are not just some academic exercises. They form the theoretical bedrock for creating more human-like artificial intelligence. They're what power the insights of behavioral economics. They let us design better educational tests, guide actual neuroscience research, and even build tools to help improve medical decision-making.
And ultimately, what all this means is that every time we create a better mathematical model of the mind, we gain a deeper understanding of ourselves. And that understanding, that's the first step toward building smarter, more helpful technology and creating better ways for us to learn, to decide, and to live.
It really is a profound thought, isn't it? The more we succeed in mapping this intricate mathematical landscape of the human mind, the more we start to realize the true scale of the territory we're dealing with. The map isn't the end of the journey, it's the beginning of a whole new kind of exploration. And what we'll discover next, well, that's anyone's guess.